Welcome to this overview on the thoracic viscera. Our purpose here is to provide you major take-home messages and to avoid excessive detail within this particular lecture. This slide lists the objectives that you should be able to answer at the conclusion of this presentation. First, list the three major compartments of the thoracic cavity. Describe the topography of the lungs. Describe the boundaries and divisions of the mediastinum. List the major viscera or organs located in each of the divisions of the mediastinum. Describe the surface topography for the auscultation of cardiac valves. Describe the general function of the thymus gland and its mediastinal location. Then we'll summarize the key take-home messages and then provide attribution for the images that were used throughout this lecture. Here is our body map, and our focus will be anteriorly, approximately in this area of our body map. And then posteriorly, our focus will be generally deep to the area within this region. This slide is an illustration that demonstrates the three major compartments that exist within the thoracic cavity. Two of these compartments are pleural cavities. The right pleural cavity is shown here. It harbors the right lung, so that would be its resident. Here on the left side, we see the left pleural cavity, and its occupant will be the left lung. Between our two pleural cavities, we have this area standing in the middle of the thoracic cavity. This is the mediastinum. Also of note is the fact that we have a nice cardiac or heart window right in through here, and part of that window is provided by the fact that the left lung gets displaced toward the left side of the thoracic cavity, towards its own pleural cavity, and there's a notch created by the impression of the heart. This allows access to the heart if an intracardiac injection needs to be administered. It also provides access to the heart if there's fluid accumulating within its pericardial cavity, and that fluid has to be withdrawn. Here we're looking at a radiograph of the thoracic cavity, and we can see the two pleural cavities as well as the mediastinum standing in the middle. The pleural cavities are going to appear relatively black. The mediastinum is going to have a much lighter appearance in its contrast. So here is our right pleural cavity, and we can see how dark it is. We can also see here on the left side, the left pleural cavity, and again we can see how dark it is, and the darkness is due to the fact that the lungs hold a lot of air, and the X-ray beam will readily pass through any air-filled structures, thereby darkening the film and providing for this nice dark contrast. We can also visualize, though it's obscured by the vertebrae, but we can also visualize the air-filled trachea. So if we look here between this vertebra and the vertebra below, you can see how darker it is. You can also see some blackness imparted here between those two vertebrae, and even up here more superiorly, you can see some areas of darkness between the bony vertebrae. This would be the air that is filling the trachea. The mediastinum then would be represented by the lighter areas that we see in through here. The major occupant within this portion of the mediastinum is the heart, and so we can see a nice cardiac silhouette. Here's the left ventricle over in through here, and then if we come over here, we can see the right atrium bulging toward the right side of the body. Here is a cross-section or axial section through the thoracic cavity. The plainest section is right along here where you see the red line. And it's very, very important that this axial section is oriented as such that you're standing at the feet of the individual, looking upwards toward the individual's head. That means that the left side of the image is then the right side of the individual. And the right side of the image is the left side of the individual. So if we go back here, here is your right lung within the right pleural cavity. Here is the left lung, that's a resident of your left pleural cavity. And then here we can see the pericardium of the heart in green, and we can see the heart muscle itself. The portion outlined here is your left ventricle. So the heart and its pericardium lie within the mediastinum. Let's now apply the illustration that we saw here to radiologic imaging. All right, let's now take a look at the thoracic cavity as viewed with CT, and we are looking at an axial section through the thoracic cavity. And again, keep in mind what appears dark versus what appears bright. And the most obvious dark areas are these huge regions right in through here. This would represent air in a lung, and since this is the left side of the image, this is the patient's right lung. We also have a large area that's dark on this side of the image, which would be the patient's left lung, and then we see some areas that are bright. This area represents blood flow. The blood is flowing through your ascending aorta. It is coming towards us as we view this image. The ascending aorta would go into the arch, and then the arch will curve to the left posteriorly, and we'll pick that descending portion of the aorta up along the left side of the vertebral column. And again, it appears bright because of the blood that's flowing through it. We also have in this area a bright spot, again representing blood flow. This is blood flowing through the superior vena cava, and it's going to empty into the right atrium. And if we look within the substances of the lung, we can see these bright areas that have a branching pattern. We see the same kind of bright branching pattern within the left lung, and since these are bright areas that have branching, these branching patterns represent blood flow into the lungs. And then if we take a look here and here, we see two luminous profiles, and the lumen of each one of these profiles is dark. That, by interpretation, means that these structures have air within them, and these then will represent the bronchi. The substance of each lung has these bright networks within them, and they're a little bit brighter here perhaps on the right side of the image within the left lung, and again these bright streaks or networks represent blood. Our focus here on this slide is to understand the topography of the lungs, and you'll need to think about the superior topography or limit of each lung versus its inferior limit. So first, let's start with the superior limit of the lung, and we see the apex of the right lung projecting above the clavicle. We also see the apex of the left lung projecting above the left clavicle. And if we take a posterior view of the apices of the lungs, they'll have a vertebral level relative to C7, the vertebra prominens. The distance above the clavicle is about 2.5 centimeters, which would be equivalent to 1 inch. The inferior limits of the lungs are going to depend along which line of axis we're looking at or we're viewing. And we will describe 3 axes. One will be midclavicular. One will be on the lateral side of the thoracic wall, mid-axillary. And then posteriorly, we'll have one that runs along either side of the vertebral column, and that'll be a paravertebral vertical axis. If we start with the midclavicular, going to mid-axillary, going to the paravertebral, the inferior limits of the right lung and the left lung will be at rib 6, midclavicular, mid-axillary, the lung will extend down to rib 8, and then posteriorly, the inferior limit of the right lung and the left lung will extend down to the level of your 10th rib. So it's 6, 8, 10. Now I want to shift your focus to the concept of the mediastinum. Again, the mediastinum is that area between the lungs and the pleural cavities that literally stands in the middle of the thoracic cavity. So on our next slide, you'll be able to understand the various boundaries that limit this particular region within our thoracic cavity. And the first thing that we need to understand would be the boundaries of the mediastinum. And those boundaries will be an anterior boundary, a posterior boundary, a superior boundary, as well as an inferior boundary. The anterior boundary will be the sternum, and that is the structure here. The posterior boundary to your mediastinum will be all 12 thoracic vertebrae. T1 is here, 2, 3, 4, 5, 6, 7, 8, 9, 10, say a little bit of 11, and then 12 would be just a little bit below this illustration. The superior limit of the mediastinum will run from the sternal angle, this notch, the jugular notch that's right above the sternum, and then will extend superiorly to the upper limit of T1. The inferior boundary will be limited by the diaphragm, and as it comes around posteriorly, it will dive down to T12. The mediastinum can be divided into various divisions. We have a superior division to our mediastinum, then we have a larger inferior division, which can be subdivided into smaller parcels. So we need to understand the boundaries of these divisions and subdivisions. The first here is a separation of the superior mediastinum from the inferior mediastinum. Our reference points will be the sternal angle, which is formed at the point where the manubrium articulates with the body of the sternum. This will be at the level of the second costal cartilages that are attached then to the second ribs. So we'll run a line from the sternal angle posteriorly, and then that line will intersect between T4 and T5. Everything above is in the superior mediastinum. Anything below is a resident of your inferior mediastinum. Now again, we can subdivide the inferior mediastinum into an anterior mediastinum, middle mediastinum, and a posterior mediastinum. The anterior mediastinum is shown here in green, and it is an area that is between the sternum anteriorly and the pericardium posteriorly. The posterior mediastinum is shaded here, and I'm actually going to kind of go over here to the bronchi that are shown here and throw them into this pink shaded area. This is the posterior mediastinum, and it's located between the more inferior thoracic vertebrae and the pericardium here posteriorly. Everything else then is going to be in the middle mediastinum, and your major occupant will be the pericardium and its attendant heart and great vessels. Now we want to take a brief look at each of the mediastinal areas, and the purpose of taking a look or a stop at each one is to understand the major or key viscera that are occupants of these mediastinal divisions and subdivisions. So the superior mediastinum will have the trachea that we see here, and then running posterior to it in the superior mediastinum will be the esophagus. In the superior and anterior mediastinum, up until puberty and a little bit beyond, your major occupant that will reside in both of these mediastinum collectively will be the thymus gland. The thymus gland reaches its maximum mass at around puberty, and that mass is in the neighborhood of 35 grams. Thereafter, it involutes, and so we have a degeneration of the thymic tissue, so very little remains in an elderly person, and what does remain is scattered within adipose tissue that would be located within these mediastinal compartments. The major function of the thymus gland is to educate our T lymphocytes so that then they are able to recognize self-antigens. And if this educational process goes awry, that can lead to autoimmune disorders. Our middle mediastinum is depicted here. The pericardium is shown, so that would be an occupant of the middle mediastinum. Lying deep would be the heart, and the initial segments of the great vessels would also lie within the middle mediastinum. When we think about the heart within the middle mediastinum, and we think about cardiac valves, the 4 cardiac valves, a very important part of the physical examination is to listen to the cardiac valves in your patients. There are topographic relationships that you need to bear in mind to best auscultate the cardiac valves. And so if we take a look here, we have the aortic valve being depicted here, and note the vector of blood ejection going up into the right side of the body. This is then the optimal location to pick up the sounds that emanate from the aortic valve, and this area is in the right second intercostal space. We also have, right in through here, the pulmonic or pulmonary semilunar valve. And again, if you follow the vector of blood flow out through this valve, you will see that the best area or the optimal area to detect closure of this valve is going to be in the second intercostal space as well, but in the left intercostal space. If we take a look at our atrioventricular valves, which lie here and here, here's your tricuspid. And the best location to pick up auscultation from the right atrioventricular valve is going to be in the left fourth intercostal space. And then here's the vector that's associated where we can best hear the closure of your left AV valve, and that is at the level of the apex of the heart. So that's going to be in the left fifth intercostal space. The posterior mediastinum, this region will house the esophagus. And so if we take a look here, we have the esophagus extending from the superior mediastinum into the posterior mediastinum. We can also see the divisions of the trachea within the posterior mediastinum. Here in this right view, we see the right bronchus, and on the left side, we would have the left bronchus. Some authorities, some anatomists, will assign the primary bronchi into the middle mediastinum, but others will assign these, as I am, into the posterior mediastinum. I think it's simpler to keep that in mind because anything posterior to the posterior pericardium is then in the posterior mediastinum. And now we can do a brief quizzing session or moment with you to see if you kind of understand where we are within the thoracic cavity. And so we could take a look here at this particular structure and note its relationship to other structures within the thoracic cavity, such as the heart, and then we have our lungs. And so where are we within the mediastinum? Since we are posterior to the heart, this is the esophagus within the posterior mediastinum. If we take a look over here, where are we within the thoracic cavity? Left side of the image, but again, we're viewing this as if we're standing at the feet of a patient looking up toward their head, so this would be the right pleural cavity. Now let's summarize the key take-home messages. The thoracic cavity is divided into three major compartments. We have two pleural cavities, and we have that area standing between them in the middle of the thoracic cavity called the mediastinum. The apex of each lung extends above the clavicle to the level of C7 for the vertebral level, and the inferior limit of the lung will correspond to ribs 6, 8, 10. The mediastinum is divided into superior and inferior divisions by a plane that runs from the sternal angle to an area that is located between T4 and T5. The middle mediastinum is best defined by its major occupant, the heart and pericardium, with the other subdivisions of the inferior mediastinum located anterior to the heart and then posterior to the heart. The points of auscultation of the cardiac valves are located in the right and left second intercostal spaces and the right fourth and left fifth intercostal spaces. The trachea is located in the superior mediastinum, as is the esophagus, and the esophagus will extend into your posterior mediastinum. And the thymus functions to educate T lymphocytes against self-antigens and is located at its maximum development in the anterior and superior mediastinum. Thank you for joining me on this lecture on an overview of the thoracic viscera.